Welcome everyone to part 4.4. In this part, we'll implement the pure pursuit controller using Unreal Game Engine and mainly using the blueprints. Blueprints are graphical programming in Unreal. Uh, it has almost the same performance as C++. It's pretty cool, and since it's graphical, you can uh, easily understand the flow there, basically, and which makes it easier for you to understand how we implement the pure pursuit controller. If you remember, from the previous two sessions where I introduced the theoretical background of pure pursuit controller, I said that we have the target point that is on the path, and it is on spline in this case, and the target point should be always ahead of the vehicle. So in the previous session, we have seen how we can get the closest points on this spline from the center of mass of that vehicle. So now we need to basically get the closest point on the spine, not from the center of mass, but from a point ahead of the vehicle. So what I will be doing in the beginning is adding here reference point, which is always, of course, attached to the vehicle. It's basically along the major axis of the vehicle, but we want to make sure that it's ahead of the point, the vehicle, sorry. And then we want to find the closest point on the path to that head point or reference point. Then we can draw, as you'll see, and also, of course, to measure the LD, we can draw the vector, the look ahead vector from the rear center, which is here, to the target point. So going back to where we stopped at the previous session, we stopped here. And I would like to start with the car physical model. So if you actually under content, vehicle advanced here, and you under vehicle, you can see here the car physical model. You can see the mesh here, the skeleton, and what is actually important for me is mesh or skeleton also works because I want to add reference points to that mesh. Let's move to the top view because it's easier to see the mesh. This is the rear center that is also important for us, and I want to look actually for the bone. This is a skeleton, which means this basically the vehicle object has a mesh, has a skeleton, and has a physical model. The skeletons always consist of bones, and in Unreal or actually in any 3D graphic software, like also in game engines like like Unity, or also in animations engines like Blender or like Maya or so. We have this basically the mesh, and we have the skeleton, which consists of bones. These bones are usually used to model the motion and also the animation of that mesh. So I want to, for example, here we have the skeleton, and what we see here basically this is one bone that is starts from the center of mass of that vehicle and ends here at the center of the right front wheel. And what I am looking for is this point here, so I need to just keep going down. It is, I know it is basically, yeah, the antenna root. So here we have actually antenna in this card, and this is basically the antenna root. So we need to copy this selected point names. We need to basically write it somewhere or keep it somewhere. Just keep it in mind because we will use it later. And this is basically the antenna root. Before we use antenna root, I said we need to add here a reference point. So how to do that? If we, let's say we are here under antenna point, and I need to add a virtual bone, or let's add a socket here. And now this, you see, it's basically this virtual bone, which is has a name socket here. We can rename it as you will see, but let's now move it because we can now move this point. We don't want it to be here. We want it to be ahead of the vehicle. So I want to move it to the right and put it here. It's fine. This would be our reference point to get the target point on the spine. So I'm not. It's basically if not here, then we can. Let's save first. Then we can. I think under skeleton we can change its name if we can find it. So if we go here. Maybe it's better to. Okay, we can rename it. So this one I don't need. Remove or delete selected. This one what we want to rename. And I would like to call it, let's say, front reference. That's it. And here we have on the antenna root. Just remember these two now important for us. Now, if I save here, so let's go back here and open the blueprints here of our vehicle. And here we have a bit of mess. I want to organize it a bit. So this is basically operations that happens in the beginning of the game. This one. And we can just copy this, put it here. Then we have the target speed. So this is the PID controller. What we can do, since basically this is the PID controller of the speed now, and there's nothing we need to add in this moment. So we can select collapse nodes and here put speed PID controller. Okay, that's better. So now previously our reference point was the world location, which is the center of mass of our mesh. And what I want to actually replace that with get here. No, get socket location. And no, okay, transformation, get some, yeah. So we need here to put the socket name, and just the first or the important one is basically the front reference. So I'm copying that, putting this here, then put that there, connect them like this, and let's see if it works first. Yeah. So let's plot a line that shows us basically the vector first from the front reference to the closest point at this point. So we have what is called draw debug line here. And from its name, basically this line will be always only visible in the debug mode, so not when they deploy the game, but we are doing simulation here, so it's fine. And we connect that here. The first point is that, the second point is that, and we need to give it color. That's purple. Let's take red. And duration, for how long this line would be visible. So I'll put 1, and it will be always actually updated because you are ticking. And thickness, let's try 10. Compile, save, and play. We see now we have this line. For some reason, I think because we have the duration, it's quite long. But let's look at it from this view. Okay. And let's look at it from here. Yeah, because you can see this is we are many lines because the duration is quite long. So we can put 0.1 so you don't see many lines. Yeah, that looks fine. So this is basically now the vector between the front vehicle and or the front reference point and the path or spline. I think we need to move that bone or that reference point a little bit more ahead because it's not really a head vector. But let's keep it as it is now because it might be enough. What is important for the pure process controller is not this vector, actually the second vector, which is from the rear center, which is here. Actually, it's called, in our case, let's copy it from there. It's better. The antenna root. So seems I lost it there. This one. So rename if we can. Let's go skeleton. To rename. Okay, sometimes I can rename, sometimes I cannot. Why? Yeah, just copy selected one name. Okay. Next, we need to copy that name here. And this should stay the same because this is basically, let me put it in this way as well. So collapse, and here we call it get or get target point. And then so this is basically our target point. So this is not what we want. And I want to delete the second output. So we have two outputs. Okay, this one we don't need. And we go here. Yeah, because all right. So now we need to draw this vector from the real center to the target point. Okay, it's compiling. I don't know when did I click compile. Compile is finished. One thing I did wrong in the before compile is that I connected the spline to here, but no, we need to get the socket from the mesh, not spline. And then we connect it there, as I said. then you compile, save, and press, and you see now it's basically our vector is from the rear center to the look ahead vector. I still think we need to push the reference point, or the front reference point, a little bit more ahead. Let's look from here. This is basically the vector. Okay, it's better to do that. So this was it, yeah. And top, move, let's put it more ahead. Save. Yeah, that's better. So it's the reference point, the target point is the head of the vehicle. Okay, so this is basically now the head vector. So what we have done here, we get the head vector. So I want to store now these vectors and these points to use them in other part of that code. So the first thing to do is basically let's create here a variable. I want to call this variable the target point. What's public or not, it's not that important here because we're using within the vehicle. It is a vector, and I want basically to set this value as my target point. So this set needs, of course, an execute. So I would add here another input that should be an event or execute. Okay, so this is actually the ticker. So here I will call it tick. And so in Blueprint, you can just also to make it more organized, you can do routing. Now it looks better. And let's put this here. All right. So this for get target point. Now here I want to also, I want to create the vector that basically that we have just here plotted. So vector is basically represented by 2 points, of course, in the 2D here or in 3D, and so our vector is the point, basically the coordinate of the endpoint minus the coordinate of the first point. So to do that, let me, okay, so let's delete this one and promote that to a variable. And I call this now, so this is not the target point, but this is the rear center. And this one, we are setting it. So this one is actually not important to me anymore. If you want to execute sequence or sequential steps here, it's also, we have a very nice option called sequence here. So at the beginning, actually we can move that. Let's keep it there. And the first thing I want to do is to set, or actually to the rear center. And this is now good, fine. Maybe if we want to plot it now in the second step, we can, of course, do that here. And so, okay. Yeah, so I will collapse that and call it get rear center. And now here we need to get the vector. And for that, we can now use, if you just write here minus and get the float, this is basically a way of now subtracting, as I said, the target point from the reference point. But we can also use the vector differences. So if I have that here, so it's vector minus vector. As I said, the target minus the, oops, the first point. So this is our target. And, or actually, let's just to be also more organized. We can now get this and get that, connect the target here. Then here, we can promote that to the look ahead vector. Okay, this is basically our second point, and we can do that. Collapse. Get look ahead vector. All right. And let's compile now, save, just to make sure that nothing wrong. Okay. So the next step would be now is basically to calculate the vector length. So basically the look ahead vector, which we need LD in our control formula here. Okay, so we need alpha, we need LD, and we need the distance also between the rear center and the front center here. So we need also to get that. And so let's start with the LD. Moving back to our game, open our blueprint here. Let's add another pin because this would be the next step. So we can get easily that vector length, just like this. I need also to promote that to a variable because it makes everything easier. So I lost part of the video, unfortunately, but I will repeat what I have done to create LD or to get LD and L. The first thing we need to do is to go to the skeletal mesh and add another point which represents the front center. So it's the same way we created the front reference, we can create the front center because we need to get this L, which is the distance between rear and front. Next, so for LD is just how we ended up. So we ended up here. And now I'm setting just a new variable. It's called LD that would represent the value that comes there. So this is the length of the look ahead vector. Now, next L, how we calculate it. So the same way we get now the coordinates of the front center, which is the bond that we have created or the socket we have created. Then we are setting their values to, or it's actually coordinates to a variable here. It's called front center, the type vector, just to store it. And then we calculate, or we get the main axis, what is called, or which is the vector between
the rear and front centers. So we have two points here. We get the difference between them to get the vector between them. And here we can get the length of that vector. We are setting it to a variable L. And this is basically the vector. We are setting it to main axis vector. Here we can also draw the line that's starting from the rear center and ends at the front center. So we have these two collapsed points. We can connect them to pin 3 and pin 4.
Okay, we need now to get alpha. And first of all, I found a mistake that I did before because this stick was not connected. So please connect it and then connect the rest. And how to get alpha? So we have two vectors here. We have the measure or the main vector and the look ahead vector, and this alpha is the angle between them. So if we get the orientation of this vector, which is our main axis here, and the orientation of LD, then we can, if we subtract the orientation of both of them, we get basically alpha. And that is in Unreal simple. So if I do get the main axis vector and I get the look ahead vector, here we can get the what's called the vector heading angle. And here we do then have our unit the same for the look ahead. Then if I subtract these two from each other, we get alpha. So this basically it would be in radian. And let's first just convert it to degree, just to radian to degree, just to see if it's correct or not. And let's print, no, not duration, but value. And we need to connect here. Okay. So if I click now simulate, okay, I don't see my vectors. Yeah, they're here. So pause. Frame step, frame step. So it's about 30 degree, which is basically looks somehow good. If I increase that like this, it's 55. 71. Okay, this is removed, not the car. Let's play on the selected view. So this is about 0 degree. Now it's about 35, and this is a negative, which is quite good now. Yeah, it looks good. So if we are on the right side, it's a positive. If we are on the left side, it is negative. Okay. So if we move back here, I don't want to print that anymore. Let's promote this to variable. And I do have here a variable called alpha. If you don't, you can just create a variable, call it alpha. And we set this value here. And we put that. Let's collapse these nodes and call it get alpha. Okay, so we had that's the header. Okay, so it opened. Yeah, the C++, and so this is the binding exactly. So you want to bind the move right. Compile. In the meantime, there's one thing we need to do actually here is we need to let's say reverse the sign of delta because it's not the correct sign if we look at the how we control our vehicle. So I want you to multiply it by -1. Okay, save. And now, so the last part is basically now to bind this value and to control the vehicle with alpha. So basically here we have move right. And no, not this one. We have the steering, sorry. The steering vehicle set steering angle. So this was our PID gain. Then here we have set throttle input. And here, which should be not this one, set steering input. And for that, we need, of course, delta, which is our steering input. But here I will put, or basically I will create, let's call it gain. It's not that gain actually, but let's call it delta k. Just we need to multiply the scaling factor. So here we have float, and we need to multiply them together. So, okay, and here we need to have the vehicle movement. Okay, so we'll try it once the compiler is finished. So I will not let you wait. When it's finished, I will continue. All right, so just here, one thing is basically put it at 1. If it's 0, the car would not move, of course. Save, play. So now it looks stable. Nice. Okay, see, now it's basically following the path. Oops. Yeah, this is now. Oh, yeah, we can see basically if the curve is too sharp, it's hard to respond because the car is too fast. And if you remember, even when I'm controlling when I was controlling it myself, it was hard to do that. So there are two. First thing we need to actually to reduce the speed. It's too fast anyway, even for me to control it. And I just want to check the target speed. So, oop, oop, oop. And here, okay, I don't know why I don't see where the target speeds. Hmm, that is possible here. Yeah, I forgot where is it. So let's put the target speed at 10. Why it's doing that? Okay. Oops. Okay, that was weird. Now we might need to move the look ahead vector, which means we might need to move the reference point so the car can react faster. But actually it's quite good. But now it will, let's see. Yeah, perfect. Very nice. So if we continue the track, then we win. Yes. So steering control is done. And the question now, can we also control the speed with respect to the path or respect to the curvature of that spline? And the answer is yes. And what we'll do now is adaptive speed control, where the speed first or the target speed would be calculated with respect to the spline curvature. And actually what we will use here, the the angle that we are calculating, which is a delta angle. So because if the, let's say we have large angle, that means we have basically large radius, and that means we need to slow it down. And if we have straight line or straight path, that we can speed up. So what I've done here is taking the delta value that we have already calculated, and we have here, this is basically the reference or the highest speed, which is we set it to the target speed, which is here the target speed that the PID is following. And so we have the 30 here, which is our maximum speed, which is 30 kilometer per hour. And this is basically we are subtracting for that value, and this value is a function of delta or absolute of delta because we don't care about the sign here, we care about the angle itself. So we are multiplying delta with a factor 30. The 30 is not important to be equal to the 30, the maximum speed. It's just experimentally I found that this factor is enough for the speed control. So if we do so, we get speed control plus steering control together, as we'll see. So now the car can speed up till 30, and then start to slow down when it detects a curve. See, it's basically now speed up again. Now slow down. Now it has sharp, so it's really slowing. Perfect. Now it's even sharper. Great. Now it will break. See? And perfect. So we have now steering control, we have speed control, lateral and longitudinal control together, which is almost to level 2 self-driving car. With symbolic systems, we didn't use any machine learning or deep learning system yet. In the next part, we'll implement the standard control using blueprint, like we did for pure pursuit controller. Thank you.